Hey everyone, hopefully at this point you've watched Mrs. Fineice's video on calculating instantaneous velocity, instantaneous speed, average velocity, and average speed. We're going to take just a second to review that just to make sure everyone's up to date. For instantaneous velocity, all we're going to do is find the slope of the line segment for whatever particular time we're trying to find the instantaneous velocity. If we're trying to find the instantaneous speed, we're going to find the absolute value of the slope for that line segment, because if you remember, speed is a scalar and can only be a positive number because direction doesn't matter for a scalar. Using that, we're going to find the instantaneous velocity and the instantaneous speed at two different parts of our graph. Luckily for us though, both of them fall on the same line segment. The first one asks us to find the instantaneous velocity at 7 seconds, which would be somewhere about right here. Right? Not the easiest spot to find. However, all we need to do is find the velocity by using the slope of any 2 points that fall on that line. Because once we have the instantaneous velocity for any point on a given line segment, we have it for every point on that given line segment. Using that, we're going to calculate using these 2 points, 5, 10, and 10, -5. And remember, our instantaneous velocity is just going to be our slope, delta y over delta x, which is going to be -5 minus 10 over 10 minus 5, or -15 over 5, which would give us an instantaneous velocity of -3 meters per second. And if you remember what we said earlier, all we need for the instantaneous speed would be to take the absolute value of the slope. And because 8 seconds falls on the same line segment as the 7 seconds, we can take the absolute value of our -3 meters per second, which just tells us the speed is 3 meters per second. Right? We're going to use that in a few minutes to solve some problems and to convert a position time graph into a velocity time graph. Now, velocity time graphs are going to be a little bit different because in order to find and in order to understand what the object is doing, we're going to compare our lines and we're going to compare everything on our graph to the zero of the velocity time graph. First of all, anything that is above the zero is a positive velocity, right? That's the positive section. That means it's a positive velocity. So anything that's up here is a positive velocity, which means it's moving in the positive direction. Okay, the opposite to that would be anything that falls below the zero line would be a negative velocity and therefore must be moving in the negative direction. The other thing that we're going to pay attention to is how close our line is to the zero velocity. Keeping in mind, a zero velocity means that we're not moving. The farther we are, whether it's positive or negative, the farther we are from the zero line means the faster we're going. And the closer we are means we're moving slower. Again, whether it's positive or negative, we have to remember positive and negative is about direction only, right? So the magnitude of that will actually tell us our speed. So the closer we are to zero, the slower we're moving. The farther we are from zero, the faster we're moving. Now what we're going to do is grab a position time graph and we're going to turn it into a velocity time graph. What we want to do is look at the different sections that are depicted in the position time graph, right? You'll notice they're already listed, A, B, C, and D. This is just the position time graph from before. In order to calculate the velocity in segment A, I'm going to take the slope, right? So I'm going to use the 2 points, 0, 0, and 5, 10, and I'm going to calculate my slope. Right, so I'm going to get 10 minus 0 over 5 minus 0, and that tells me that my velocity for segment A would be 2 meters per second. I'm going to come down to my velocity graph, and I'm going to draw a constant velocity at 2 meters per second. We've already calculated, because this is the same graph from before, we've already calculated the velocity for section B. If you remember, that velocity was negative 3 meters per second. So we're going to drop down, because it's right from the 5-second mark to the 10-second mark, we're going to drop down and we're going to draw a constant negative 3 velocity from 5 to 10 seconds. Now you can, some people do, some people don't, you can draw little dotted lines so that we know that those are representing the same kind of starting and ending position. Right, for the next section, section C, notice we started at the position of negative 5 and we ended at the position of negative 5, which means our velocity from the 10 to the 25-second mark must be 0 meters per second. So we're going to put that right there on the axis. Lastly, our last section here, D, we're going to calculate the slope again, and this is 25 comma negative 5, and this would be 30 comma 0, right? So if we take our slope here, we're going to have 0 minus negative 5 over 30 minus 25 is 5 over 5, or a velocity of 1 meter per second. So I'm going to take my 25 seconds to my 30 seconds mark, and once again, we've got our constant velocity. So again, when we're looking at a position time graph, it's mostly about the slope to figure out what the object is doing. When we're looking at a velocity time graph, we have to pay attention to how close we are to the 0 and whether or not we are on the positive or the negative side. If you've got any questions, feel free to reach out to Mrs. Feineiss, Mrs. Golder, or myself.